In this video, we are going to make a general revision on qualitative analysis with respect to the Cambridge Igcse and Gcse, Gce O levels, and the West African Senior School Certificate exams. Precisely, we will be dealing with the effect of adding aqueous sodium hydroxide solution to solutions containing various metal ions, and the effect of adding aqueous ammonia solution to solution containing various metal ions too. In this situation, we are going to make a review of the different salt solutions, observations, and inference. But before we continue, I want to thank those of you who have taken your time to subscribe to this channel. But for those of you who haven't subscribed to this channel, please like this video, share to other learners, and most importantly, take some time and subscribe to this channel. Thank you for taking your time to subscribe to our channel. Let's get started. Qualitative analysis, a general revision for the CIE, Igcse, Gcse, Gce O levels, and West African Senior School Certificate Examination practical exams. The first section of this qualitative analysis would be studying the effect of adding aqueous sodium hydroxide solution to solution containing various metal ions. We have three columns here. The column of observation of the salt solutions, the column of adding to excess of the sodium hydroxide solution, and our inference column, that is the likely cation that is present in the salt solution. Okay, for instance, here, take for instance, we have a salt solution. We have a salt solution. After adding aqueous sodium hydroxide solution to the salt solution, our observation is white precipitate are formed. White precipitate are formed. Then, on adding aqueous sodium hydroxide solution to excess, the white precipitate will dissolve. Our inference, or the likely cation that are in this salt solution, would be aluminum ion, zinc ion, or lead ion. Secondly, taking another solution, on adding aqueous sodium hydroxide solution to that salt solution, our observation would be white precipitate. If white precipitate are formed, and then we add this aqueous sodium hydroxide solution to excess, and our observation is that precipitate does not dissolve, it shows that the likely cation that is present in that solution would be calcium ion. Now, we have another salt solution. In the salt solution, we add aqueous sodium hydroxide solution, and we observe that it's a blue precipitate that is formed. On adding the aqueous sodium hydroxide solution to excess, we realize that the precipitate does not dissolve. Then the likely cation that is present is copper 2 ion. The same goes with a solution, with another solution, that when we add aqueous sodium hydroxide solution, it turns, the observation is green precipitate are formed. Then when we add to excess, we realize that the precipitate does not dissolve. Then our inference, or the likely cation present in this salt solution, will be what? It will be ion 2 ion. Ion 2 ion. Now, let's take another salt solution. This is another salt solution if we add aqueous sodium hydroxide solution to this solution, to this salt solution. And our observation is that brown precipitate are formed. Then we continue to add to excess, and we realize that the brown precipitate does not dissolve. Then the likely cation present in it is ion 3 ions. And above all, if we have another salt solution, and then we add aqueous sodium hydroxide solution to it, the observation, and we observe that light green precipitate are formed. Then we proceed to add to excess, to add excess of sodium hydroxide solution, and we realize that the precipitate dissolve. Then our inference, or the likely cation that is supposed to be in this solution, will be chromium 3 ion. Let's move forward. Let's move forward to the effect of adding aqueous ammonia to these solutions. The effect of adding aqueous ammonia to the various solutions we have just added above. Should in case we are using but aqueous ammonia this time around, aqueous ammonia in this time around, and we add the very salt we added sodium hydroxide reaction with sodium, aqueous sodium hydroxide. This time around, we use that the salt solution to add but aqueous ammonia solution to it, and observe that a gelatinous blue precipitate is formed. And then we proceed again to adding excess of aqueous ammonia, and we observe that the precipitate, the gelatinous blue precipitate that were formed, dissolve to give a deep blue clear solution. We will conclude that the cation present in it is a copper 2 ion. If we take a salt solution, the same solution we used above, this time around, we add aqueous ammonia there, and we realize that our observation is a dirty green precipitate. Dirty green precipitate is formed. And then we proceeded in adding the aqueous ammonia to excess, and realized that precipitate does not dissolve. Our conclusion, or our inference, will be ion 2 ions are present in that solution. Then take for another solution. Take another salt solution. We add aqueous ammonia. If you take another salt solution, an unknown salt solution, and you add aqueous ammonia to it, and you observe that a rust brown precipitate is formed, then you add aqueous ammonia to excess, and you observe that precipitate does not dissolve, your conclusion should be that ion 3 ions are present in that solution. Then let's move forward. Should in case we have a solution, another salt solution, and an unknown salt solution, and then we add aqueous ammonia to it. Aqueous ammonia to it, and we observe that white precipitate are formed, or white precipitate is formed. Then we proceed in adding the aqueous ammonia, in adding the aqueous ammonia to excess, and we realize that, or we observe that, the white precipitate does not dissolve. Our inference, or the likely cation that is there, is aluminum ion. Aluminum ion are present. Then let's take another unknown salt solution. Let's take an unknown salt solution. We add aqueous ammonia to it. We add aqueous ammonia to this solution. Our observation is white precipitate again. Then we add the aqueous ammonia to this solution to excess, and we observe that this time around the white precipitate dissolve. Then our conclusion, or the likely cation present, will be a zinc ion that is present there. Again, if we take another unknown salt solution, we add aqueous ammonia to it, and no precipitate is formed. Then we proceeded in adding the aqueous ammonia to excess. No precipitate again is formed. No precipitate is formed, that is no reaction. No precipitate is formed again into excess. On adding aqueous ammonia to excess, no precipitate is formed or no reaction. Then our conclusion is that calcium ion is present. Above all, if we should take another unknown salt solution, we add aqueous ammonia. We add aqueous ammonia dropwisely, and we observe that a light green precipitate is formed. Then we continue, add the aqueous ammonia to excess, to this light green precipitate, and we observe that precipitate dissolve to some extent. The precipitate dissolve to some extent. Our conclusion is that the cation present, or the likely cation present, would be chromium 3 ion. So these are the reactions we can have when reacting with aqueous sodium hydroxide and with aqueous ammonia to unknown salt solutions. Okay, now let's proceed. Testing for anions. Testing for aqueous anions. Take for instance, we are starting with the anions, the test, and the result that you will see. Take for instance, we have a solution containing a carbonate. We have just a carbonate. Any solution containing a carbonate, and you add dilute acid to it, and your observation is this: if you observe effervescence, or in your observation you find that there is effervescence, or you find that there is effervescence, or what we call fizzing, or what we call bubbles of gas being released, then your conclusion should be that carbon dioxide is being produced. For instance, if I give you a metal carbonate, let me say sodium carbonate, or calcium carbonate, this calcium carbonate or the sodium carbonate, I add dilute acid to it. For instance, dilute hydrochloric acid to it, to this metal carbonate. Let me say calcium carbonate or sodium carbonate. What you will observe in the test tube is there will be effervescence. You can say effervescence, you can say fizzing, you can say bubbles of gas are released. And your conclusion should be that there is a carbon dioxide that is being produced. So it should get into your brain that when a dilute acid reacts with a metal carbonate, carbon dioxide is being produced. A gas is being produced. And this gas, if tested with lime water, will turn lime water milky. So that is a test for carbonate. If dilute acid is added to a carbonate, there is a gas that is being produced that turns lime water milky. Okay, let's go on the halides. The halides. We are starting with chloride ion in solution. If there is a solution containing chloride ion, if there is a solution containing chloride ion and you add dilute nitric acid followed by aqueous silver nitrate, the observation you will see indicating the presence of chloride ion will be white precipitate formed. Now, if you have bromide ion in a solution, or in other words, if there is a solution containing bromide ion and you acidify it with dilute nitric acid, followed by adding aqueous silver nitrate solution, the observation will be that there will be a cream precipitate that will be formed. And lastly, iodide ion in solution, or if you have iodide ion in a solution, or a solution containing iodide ion, you add dilute nitric acid, and then later on you add aqueous silver nitrate. A precipitate will be formed, and that precipitate is a yellow precipitate. So between the halides, the test for halide, test for chloride ion, test for bromide ion, and test for iodide ion, the reagent we use will be dilute nitric acid and silver nitrate solution. Dilute nitric acid and aqueous silver nitrate. And the observation of the observation will be, for chloride we will have white precipitate. For bromide we will have a cream precipitate, and for iodide we will have a yellow precipitate. These are the tests we use in identifying the different halides using dilute nitric acid and aqueous silver nitrate. Let's go for the test for nitrate. In testing for nitrate, if you have a solution that contains nitrate ion, they test to identify that there is nitrate ion in that solution, add aqueous sodium hydroxide solution. Add aqueous sodium hydroxide solution there. After adding aqueous sodium hydroxide, then add aluminum foil. Then warm gently. Just warm it gently. There will be a gas. What you will notice after adding sodium hydroxide followed by aluminum foil and warm gently, what you will see will be bubbles of gas are being produced. There will be a gas that is being released, and this gas will turn damp red litmus paper blue. It will turn damp red litmus paper blue. and indicating that it is ammonia gas that is being produced. So if you are asked to give the test for nitrate, so just say in a solution containing nitrate, add aqueous sodium hydroxide solution, followed by aluminum foil, and warm gently. Ammonia gas is being produced that will turn damp red litmus paper blue. That is the test for nitrate ion. Then the test for sulfate ion. The test for sulfate ion. Any solution containing sulfate ion, add aqueous barium nitrate there, or barium chloride. Any solution that contains a sulfate ion, to identify the presence of sulfate ion there, add aqueous barium nitrate or barium chloride. And the observation will what? A white precipitate is formed, indicating the presence of sulfate ion in that solution. But if it is a solution containing sulfite ion, a solution containing but sulfite ion, add dilute hydrochloric acid, warm gently, and test for the presence of sulfur dioxide. Add dilute hydrochloric acid, warm gently, and test for the presence of sulfur dioxide. Then, our observation will be that sulfur dioxide produced will turn acidified potassium manganate 7 from purple to colorless. So when you add, in this case, when you add the hydrochloric acid, the dilute hydrochloric acid and warm gently, and then to be sure of the gas that is being produced, you now add aqueous potassium manganate 7, which is purple. If there is a color change from purple to colorless, then sulfur dioxide gas is being produced, and that is the test for sulfite. Thank you for listening. A recap. Under this qualitative analysis, we just discuss on the reaction of aqueous sodium hydroxide solution with salt solution, unknown salt solutions, and the reaction of aqueous ammonia with different salt solution. And finally, we tested for anions. We tested for carbonates, halides, nitrate, sulfate, and the sulfite. From there, because you could be asked to give the test for any halide or nitrate or sulfite, you can use this information in describing the test for them. You could also be given a table to identify the different cations, the given unknown salt solution. Based on this, their reaction, and the reaction when you add to excess, you'll be able to know the likely cation that is present. Thank you for taking your time to listen to this. Wishing you best of luck. Thank you very much. Once more, for those of you who haven't subscribed to this channel, please like this video, share to other learners, and most importantly, take some time and subscribe to the channel. Thank you.